Hello students, I, Rohit Shah, Assistant Professor in Department of Commerce, Shyam Lal College, is back with the second lecture of Mathematics of Finance. Previously we had discussed simple interest and compound interest. Today we would be discussing interest compounded continuously. So when we talk about interest being compounded continuously, we mean to state that interest is not compounded either monthly or quarterly or annually. Here, interest is calculated on every minute, every second, or even you can say every microsecond. The smallest unit of time that you can denote in that the interest would be computed. So then the question arises, what would be our M? So when interest is being compounded continuously, our M becomes infinity. So when interest is compounded continuously, we no longer will be able to use this formula for computing amount. So we derive a fresh formula for computation of amount, which is amount is equals to P e to the power RT, where e is exponential. R is the rate of interest, which is annual rate of interest, T is time period, and P is as usual principal. So the value of e to the power RT, we will derive it from the tables. So let's try to understand this by a question. The question is, a person deposits rupees 5,000 in a bank which pays an interest of 11% per annum compounded continuously. So here you can see that interest is being compounded continuously. So how much will the amount be in his account after 10 years? So the things that we know here is principal amount that he had deposited is rupees 5,000. We also know the rate of interest, which is R, which is equals to 11%, which is 0.11. We also know the time period, which is 10 years. Since the interest is being compounded continuously, the formula for amount becomes amount equals to P e to the power RT, which makes it to P is 5,000, e to the power R, which is 0.11, and T is 10, which makes it to 5,000 exponential, that is e to the power 1.1. Now we will look for the value of e 1.1 in the exponential table. Now we will move towards the back side of the book, and in the table of exponential we will search for 1.1 in the x column. So in the x column 1.1 we get it here. The value of 1.1 is 3.0042. So here it becomes 5,000 into the value of e to the power 1.1, which is 3.0042. So now we multiply 5,000 into 3.0042 and we get rupees 15,021. Hence the amount will be rupees 15,021 if 5,000 is compounded continuously at the rate of 11% per annum for 10 years. Now we will do one more question of this topic and then we will wind up this topic. So now let's move to another question. A national savings certificate costs rupees 15 and realizes rupees 20 after 10 years. So find the rate of interest involved if it is added yearly or continuously. So in the first case the compounding is being done yearly, in the second case the compounding is being done continuously. So if compounding is done yearly, our M is equals to 1. P is rupees 15, amount is rupees 20, time period is 10 years, and we need to find the rate of interest. So now we can compute our n is equals to t multiplied by m, which is equals to 10 into 1, which is 10. I equals to r divided by m, which is equals to r divided by 1, which is equals to r. Since we all know that amount is equals to p1 plus I to the power n, which implies amount is given to us rupees 20. So 20 is equals to 15 in brackets 1 plus I to the power n, which is 10, which implies 20 divided by 15 is equals to 1 plus I to the power 10, which implies 1.3333 is equals to 1 plus I to the power 10. Now we take log on both the sides. So this becomes log 1.3333 is equals to 10 log 1 plus I. So for the value of log 1.3333, we look into the log table. So here is the log table. So here is the log table, and we need to find the value of log 1.3333. So while finding the value of log, we eliminate the decimal and consider only the digits. So what are the first two digits? The first two digit here is 13. So now we look at the log table for the value 13. 13 is here. Now in 13, the next digit here is 3. So we go to the third column. In the third column, we get a value 1239. 13, third column 1239. So we write here 1239. Now we also have a digit after this, which is 3. So next we go to add-on bar and search for 3. This is termed as add-on bar. In the add-on bar, we search for 3. In third column, we have again 10 here to add. So we add 10 to 1239. This makes it to 1249. Now we put a decimal point here, and what would be here? The formula for the value that would be here is number of digits before decimal subtracted by 1. So the number of digits before the decimal is 1. Again subtracted by 1, we get 0. Hence we will put 0 here. So the value of log 1.3333 becomes 0.1249. Now one thing to note here, if the number of digit before the decimal is 0, in that case we cannot apply this. Then we have to apply a different concept that we will be doing later. So we got the value of log 1.3333, which is 0.1249 is equals to 10 log 1 plus I. Now we divide the 10 here, so it makes it 0.01249 is equals to log 1 plus I. Now we need to remove log here, so what we do is we multiply by anti-log on both the sides. So this becomes anti-log of 0.01249 is equals to 1 plus I. Anti-log multiplied by log, it gets cancelled, and here it gets multiplied by anti-log. Now we need to find the value of anti-log 0.01249. So to find the value of anti-log of 0.01249, we move towards the anti-logarithm table, which is given in the back side of the book. So while finding anti-logarithm of any value, we consider only the digits after the decimal. So the digits after the decimal is 01. Hence we will look for 01, 0.01. 0.01 we get here. After 0.01, the next digit is 2. So the next digit is 2 here, 2. In 2, what do we get? 1028. So we write here 1028. The next digit is 4. So we look for 4 in the add-on bar. And while looking for 4 in the add-on bar, we get 1. So we need to add 1 here. So this becomes 1029. So now we need to put a decimal in 1029. So the formula for putting decimal here is the value of the digit before decimal plus 1. So here the value of the digit before decimal is 0. So this becomes 0 plus 1, which is equals to 1. Hence we will put decimal after one digit in the obtained value. So after one digit we put a decimal here. So hence the value of antilog 0.01249 becomes 1.029. So the obtained value of antilog 0.01249 was 1.029 is equals to 1 plus I. Hence we get I is equals to 0.029. Hence the rate of interest is 2.9%. Now let's move towards the second part of the question. In the second part, interest is getting added continuously, which means interest is compounded continuously. So when interest is compounded continuously, my m is equals to infinity. We know what is our principal. Principal is rupees 15. Amount is also known, which is rupees 20. Time period is also known, which is 10 years. But we need to find out our rate of interest, which is not known to us. So when interest is compounded continuously, we know that the formula of amount becomes amount equals to P e to the power RT, which implies 20 is equals to 15 exponential to the power RT. We don't know what our R is, so let it be as it is, R multiplied by time, which is 10. So this becomes 20 divided by 15 is equals to e to the power 10R, which implies 1.3333 is equals to e to the power 10R. Now we apply log on both sides. So log 1.3333 is equals to 10R log e, which implies the value of log 1.3333 we have computed previously, which was 0.1249 is equals to 10R log e. The value of log e is always equals to 0.4343. That you need to remember. The value of log e is always equals to 0.4343. So after solving this, we get the value of R, which is equals to 0.0288. Therefore our rate of interest is 2.88%. Now the next topic is compound amount at changing rates. Now what does this mean? This means that in the initial years we will be charging a different rate, in the middle years we will be charging a different rate, and then in the later years we will be charging different rates. So there will be 3 or 4 or 5 different rates which we will be charging in different periods at different intervals. So let's understand this concept by an example. So in this particular question, Mr. X has deposited rupees 10,000 in a bank for 13 years, offering interest at the rate of 6% compounded half yearly for the first 2 years, at the rate of 12% compounded quarterly for next 3 years, then 18% compounded monthly for next 3 years, and then compounded continuously at the rate of 14% thereafter. So what does this mean? This means that for the first 2 years, interest will be compounded half yearly at the rate of 6%, After that, for the next 3 years, interest will be compounded quarterly at the rate of 12%. After that, for the next 3 years, the interest will be compounded monthly at the rate of 18%. So how many years done? 3 plus 3 plus 2, which is 8 years. 13 minus 8, which is 5 years. So for the remaining 5 years, interest will be compounded continuously at the rate of 14%. So let's solve this. So the formula for amount in changing rates is principal multiplied by first rate to the power n, multiplied by second rate to the power n, multiplied by third rate to the power n, and if it is compounded continuously thereafter, then e to the power rt. So our principal is rupees 10,000, so we put 10,000 here. Then we have 1 plus I1. What is the first rate? First rate is 6% compounded half yearly. So if it is 6% compounded half yearly, which means that my M1 is equals to 2, my R1 is equals to 6%, which is 0.06. My T1, that is time period for this rate, is 2 years. So my T1 is 2 years. So I can compute what is my I1 here. My I1 is, the formula for I1 is R1 divided by M1, which is equals to 0.06 divided by 2. M1 is 2 because it is compounded half yearly. So I1 becomes 0.03. So 1 plus 0.03 to the power n1. Our n1 becomes T1 multiplied by m1, which is 2 multiplied by 2, which is equals to 4. So our n1 is 4 here. Next we have 1 plus I2. I2 is the second rate of interest. Now what is the second rate? Second rate is 12% compounded quarterly. So if it is compounded quarterly, my M2 becomes 4 because compounding is done 4 times a year. Second rate is 12%. And the time period for the second rate is 3 years. So we can calculate our I2. I2 is R2 divided by M2, which is equals to 0.12 divided by 4, which is equals to 0.03. So our I2 is 0.03 to the power n2. N2 is T2 multiplied by M2. M2 is 4 because compounding is done 4 times a year, and time period for second rate is 3 years. So this becomes 3 into 4, which is equals to 12. So our n2 is 12 here. Next is 1 plus I3. So 1 plus I3. For I3 we need to look after the third rate. Third rate is 18%. So third rate is 18%, which we can rewrite as 0.18, which is compounded monthly. So our M3 is 12 because compounding is done 12 times in a year. For how many years? Time period is 3 years. So T3 is again equals to 3 years. So our I3 becomes R3 divided by M3, which is equals to 0.18 divided by 12, which is equals to 0.015. Hence we put the value of I3 here, which is 0.015 to the power n3. Now what is our n3? N3 is equals to T3 multiplied by M3, which is equals to 3 multiplied by 12, which we get 36. 12 3 36. Hence our n3 is equals to 36 here. Next we have e to the power rt. E to the power r. R is the rate at which interest is being compounded continuously, which is 14%. So here it becomes 0.14 in brackets multiplied by time. What is the time period for compounded continuously? The time period for compounded continuously is the remaining time period, which is 13 minus 2 minus 3 minus 3, which is 13 minus 8, which makes it to 5 years. So the third time period is 5 years. So this becomes a to the power 0.14 multiplied by 5. So now we solve this ahead. So this becomes 10,000 multiplied by 1.03 to the power 4 multiplied by 1.03 to the power 12 multiplied by 1.015 to the power 36 multiplied by exponential to the power 0.70. When we multiply these two, we get 0.70. Now we get these values from the back side of the book in the given tables. So 1.03 to the power 4. For that, we will move towards the back side of the book in the compound interest table. Here you can see it is the compound interest table. Formula is 1 plus I to the power n. Please note we will be using this formula. P is the missing thing here, so that's the reason we are multiplying P here. So 1.03, for this we will be looking at 3%. So 3% here is here 0.03 to the power 4. So the value that we get is 1.1255. So we will write it here, which makes it to 10,000. Next is again 1.03 to the power 12. So again in the same table, for 3% we look for n is equals to 12. So for n equals to 12, what do we get? We get 1.4257. So we will write this figure here, 1.4257. I have written 1.4257 in place of 1.03 to the power 12. Next rate is 0.015. So now we will again look into the table and find the value of 1.015 to the power 36. So here is the 0.015 compound interest table, and in 0.015 we are looking for 36. So the value that we get is 1.7091. Hence we use this value here. Next we need exponential to the power 0.70. Hence we move towards the exponential table. So here is the exponential table, and here we search for 0.70 in e to the power x column. So for 0.70 the value is 2.0138. We use this value. So we have written the value of e to the power 0.70, which is 2.0138. Now we multiply all these values and get the final answer. So we get the value 55,227.76. So this is the amount which will be in our bank account after 13 years if this schedule of interest at different rates is followed.